So the question is, if this is the depth versus clock time for water flowing out of the container, when we have just a short tube in the outflow, what's it look like if you have a longer tube? Sydney?
Okay, so where the tube is longer, the pressure is going to be lower. So it's going to take, of course, longer for the pressure. Not the pressure, for the water to come out. So instead of the first start will always start at the same point, of course, because it's 0 time, and it's the same depth. But it's going to take longer for the time to still get there, even though it's going to still be the same depth. It's going to be a different time. So it's, instead of it being here, it's more likely going to be more right here. And it's the same goes for all of them. It's still going to take long. It's still going to be the same depth because it's the same marking point for each one. It just takes longer for it because the pressure is lower because there's a longer tube.
So how are the two graphs going to look? What if this is one graph? If this is the first graph, what's the second graph going to look like?
It's still going to be. It's going to be flatter. Flatter, not flat. Not flat, because there's still change, but it will be flatter just because it takes longer.
Okay, so if this is one graph, can you draw what the other graph would look like? If this is a point on the first graph, you've just explained what's going to happen to that point on the second graph. What would the corresponding point in the second graph? No, draw it on the same graph so we can make a direct comparison. Exactly. That's exactly what you said. So what's the second graph going to look like? Very good. Isaac, you got anything to say here?
Yeah. Okay, let's.
You're not even involving the same original line. But you said flat. That's pretty much flat. That's not a flat graph. It is pretty much. You can't be flat because flat means straight.
No,
and it's not straight.
He could have meant flat, like it could have been a diagonal. He means no curve in the graph.
But there's always going to be a curve.
It's just a smaller curve. It's a flat curve.
That makes 0 sense.
Yeah, it does.
Do you mean flatter than the other one?
Exactly.
But you didn't say flatter, you said flat.
Flat
graph on a flat piece of paper.
We all heard what he said.
The eyes.
He even wrote it.
But see, what you did was you took the points and you measured it out differently. But see, since we're measuring depth here,
but the depth is still going to be the same.
we're always going to have.
No, it's not.
Yes, it is. The depth is always going to be the same because it's the same bottle and it's the same line.
So this is how long it takes. So, but we're still measuring
The same amount of depth. So
Exactly.
the depth is going to be the same every single time.
Then why are your points different here and here?
They're not different. They are literally the depth. If the depth is here, y is the depth, right? And that is time. The time, of course, it's going to be different for the time because it takes longer for the second graph. But it's still going to be the same depth at each point. You didn't even.
Oh.
You literally didn't even say what your case was. You literally just said the line was flat. And then you said mine was wrong, but you didn't actually give an actual statement
did.
why it was wrong.
He did give a statement.
He did.
He must